Hi everyone, in this video we're going to take a look at 6.5 trigonometric equations. Mostly we're going to focus on solving equations with sine and cosine. Okay, let's take a look at the first question together. Here it says find all solutions of sine of x is equal to 0. Now, if you think about what a sine function looks like, if we were to graph it, I forgot the section where we graph sine functions. The sine function is cyclical in that it looks like a wave function and it keeps going and going. If we were to keep going to the right, this would repeat, and this would keep repeating on the left-hand side. And so it keeps going left and it keeps going right. So what this is asking, like, where is the sine, this whole function equal to 0? Well, it's equal to 0 here, it's equal to 0 here, here, here. You can see that it has many solutions, actually infinitely many solutions. The easy way to do it is I like to use a unit circle, which I have here, and it's a good idea that you also have one out that you can refer to while you're doing the homework or the test or the quiz this week. You can look to see where is the y coordinate, excuse me, on the unit circle equal to 0. So if we look to the unit circle and looking to see where is the y coordinate equal to 0, we can see it's 0 at 0 radians. We're going to work in radians, and also 0 at pi radians. So there's two solutions on the unit circle that we can write down. So we have x is equal to 0 radians, or x is also equal to pi radians. But because this cycle repeats itself every 2 pi rotations, we denote that by adding 2 pi n, saying that this repeats, the cycle repeats every full rotation around the circle. Remember, one full rotation is 2 pi, or one full period is 2 pi. So whenever you see find all solutions, you always want to add 2 pi n to your solution that you find. So in your homework, the way you want to write this is 0 plus 2 pi n. Well, that's just 2 pi n, comma, your second solution is pi plus 2 pi n. Okay, let's take a look at the second solution together. Find all solutions of 6 sine theta minus 1 equals 4 sine theta. Solve these as you would normally, if these were x's, try to get all the variables on one side and then get all the other terms on the other side. And so I'm going to approach this the same way. So we have 6 sine theta minus 1 is equal to 4 sine theta. I like having my variables on the left-hand side, so I'm going to do that by subtracting 4 sine theta on both sides of the equation. And I'm also going to add 1 to the other side so that the number goes on the other side here. So the 1 gets canceled, the 4 sine theta gets canceled on the right. So we have 6 sine theta minus 4 sine theta, giving us 2 sine theta is equal to 1. Let's divide the 2 in front of the sine theta. And our sine theta is equal to 1 over 2. So if this were just x, right, we would be done. But because this is a trig function, we have to do one more step, which is to use the unit circle to find where is the y coordinate. Remember, this is the y coordinate, sine is the y coordinate. Where is the y coordinate equal to 1/2? So using the unit circle, the y coordinate is equal to 1/2 at pi over 6 radians, and also at 1/2 at 5 pi over 6. Because it says, again, 5 pi, find all solutions, and this cycle or the period repeats every 2 pi radians, we denote that by adding 2 pi n to our solution. So we have here theta is equal to pi over 6 plus 2 pi n and 5 pi over 6 plus 2 pi n. Again, if you see you find all solutions, remember to add 2 pi n to your solution. Okay, let's take a look at number 3. Solve the equation on the interval 0 to 2 pi. This problem, the instructions for this problem is different in that it doesn't say find all solutions. It says solve the equation on the interval 0 to 2 pi. So that means that they want to you to restrict your solutions only for the ones that you see on the unit circle. So in this case, we don't need to say or add plus 2 pi n to your solution. Okay, so here it says 2 cosine squared theta minus cosine theta is equal to 1. This is a trig equation in quadratic form. Remember, quadratic equations are where you have like x squared, where the highest power in that equation is a 2. And when we work with quadratic equations, usually we solve by factoring. And because it's hard to factor with cosine thetas, I'm going to replace all the cosines with w's. So in this case, we got 2 cosine squared. I'm going to write w squared minus cosine theta is going to be replaced with w. I could have used x, but I'm just using w equals 1. Now we have 2w squared minus w equals 1. Now the reason we do this is to make the factoring process easier for us. To factor, we need to have the right-hand side or the other side equaling 0. So let's subtract 1 from both sides of the equation. We have 2w squared minus w minus 1 equals 0. Now, I bet it's been a while since we factored, so I'm going to walk through the factoring process just to do a little mini refresher on factoring. So to factor where you have a leading coefficient that's other than 1, you're going to multiply the last and the first terms together. So I'll do this factoring work on this side. Got 2 times -1, giving us -2. And then I like to use this cross to just write my work out. The middle term is -1. So we have to come up with 2 numbers that multiplied at -2 and add to -1. Well, 2 and 1 gives us -2, but to get a sum of a -1, we've got to make the -2 negative. And then what we do, this is like a strategy that one of my former students taught me, is we can divide by the leading coefficient for both of these numbers. So we're going to divide the -2 by 2. When we do that, this reduces to -1, and also reduce the 1 by 2, divide by 2. So those are going to be included in my factor. So we got w minus 1. And then w plus 1/2. Now, if this was a factoring problem where I asked you, okay, factor this nicely, then I would change this to 2w plus 1. But because our goal is to solve, we'll just leave it in fraction form here. So now let's set both of these equal to 0. So we got w minus 1 equal to 0. Adding 1 to both sides, we have w equals 1. W plus 1/2 is equal to 0. Subtract 1/2 from both sides, we have w is equal to -1/2. Now, if this were an algebraic equation, we would say, okay, those are our 2 solutions, but it's a trig equation. So now remember how in the beginning of the problem, we had replaced or substituted w for cosine theta. So now we have to do the substitution back. So w equals 1, we're going to substitute as cosine theta is equal to 1. Or there's the other one, w equals -1/2. So we got cosine of theta is equal to -1/2. Now it's time to use a unit circle. Let me just write this equal sign again. So we're looking to see where cosine stands for the x-coordinate. So going to the unit circle, where is the x-coordinate equal to 1? Well, there's only one spot where the x value is equal to 1. That's at 0 radians. Let's write that down. So theta is equal to 0. Radians. And then where is the x-coordinate equal to -1/2 on the unit circle? Well, that happens at 2 pi over 3 and also at 4 pi over 3. So we got two more solutions from that factor. Let's write that down. Theta is equal to 2 pi over 3 and 4 pi over 3. So our solutions are 0, 2 pi over 3, and 4 pi over 3. Okay, let's take a look at another factoring problem. This is 5 sine squared x equals -3 sine x plus 8, and we want to solve this equation in the interval 0 to 2 pi, which means, again, we don't need to do the plus 2 pi n at the end of the solution. So first, let's get this to equal 0 by adding 3 sine of x, subtracting 8 on both sides of the equation. You always want to keep the leading coefficient positive. Okay, so now we have 5 sine squared of x plus 3 sine of x minus 8 equals 0. Now again, we can do the substitution where we can say, okay, w is equal to sine of x. So I can say this is 5w squared plus 3w minus 8, just to make the factoring process easier. Now let's do the same process, multiply the 5 and the -8. So here's the factoring. It's -40. The middle term is 3. And so what multiplies to -40 and adds to 3? Well, 8 and 5 gives us 40. And the way to add to +3 is make the 5 negative. So here now we have to divide by the leading coefficient, 5, 5. 8 over 5 is already simplified. We can simplify -5 divided by 5 as -1. Okay, so those are my factors. We have our factors to be w plus 8 over 5 and w minus 1. Now let's solve for 0 by setting both of those factors equal to 0. So we got w plus 8 over 5 equals 0, giving us w is equal to -8 over 5. And w minus 1 equals 0, gives us w equals 1. Okay, now we have to substitute the sine of x back. So remember here, we had said w is equal to sine of x. So w, place sine of x back and say this is -8 over 5. And then we have sine of x is equal to +1. Now -8 over 5, that's around, let's see, -1.5 goes into 8 once, and then we have 3 over 5, so -1.6. And on the unit circle, there's no value that, if you look on the unit circle, -1.6 would be down here. There's no value that's less than -1 on the unit circle. So for this right here, for sine of x equaling -1.6, x, there's no solution that'll give you -1.6. Okay, whenever you get a value that's bigger than 1 or below -1, remember that on the unit circle, everything is between -1 and 1. So x, there's no solution for this. For sine of x equals to 1, we have to look on the unit circle. Where is the y-coordinate equal to 1? The y-coordinate is equal to 1 at pi over 2. So there's only one place where that, or one angle that where that happens. And so in this case, x is equal to pi over 2. So our solution, we only have one. got pi over 2 as our solution. Okay, let's take a look at another factoring problem where it's in a quadratic form. 12 cosine squared x minus 9 equals 0. This is already set to 0, but the way you want to solve this, because there's no cosine of x term, there's only a square term, is to get the cosine squared x term by itself. So we can do that by adding 9 to both sides. And that becomes 12 cosine squared of x equals 9. And then we can divide both sides by 12 to get rid of this 12. And that leaves us with cosine squared x is equal to 9 over 12. To get rid of the power 2, we can take the square root of both sides. We get cosine of x equals, one thing to note here, when you take the square root of both sides to cancel a power 2, you get plus or minus the square root of 9 over 12. Okay, and what that becomes is you get square root of 9, square root of 12, and square root of 9, we know that's 3. Square root of 12, we can split it up as square root of 4 times square root of 3. And square root of 4 is 2, so we got 3 over 2 square root of 3. Let's rationalize by getting rid of that square root of 3 by multiplying the top and bottom by square root of 3. We have 3 square root of 3 over 2. Square root of 3 times square root of 3 is just 3. Notice how you got a 3 up here and a 3 up here, so those two cancel out. And we have square root of 3 over 2. So that was just to simplify the square root of 9 over 12. So I'm going to carry that up and say cosine of x is equal to plus or minus square root of 3 over 2. So this we got cosine of x is equal to positive square root of 3 over 2, or we also have the negative cosine of x equals negative 3 over 2. So now we look and say or ask, where is the x coordinate positive root 3 over 2? Well, the x coordinate is positive root 3 over 2 at pi over 6 and 11 pi over 6. And let's also look for where the x coordinate is negative root 3 over 2. That happens at 5 pi over 6 and at 7 pi over 6. So it looks like we have 4 solutions. For the positive root 3 over 2, we got pi over 6 and 11 pi over 6. For the negatives, we got 5 pi over 6 and 7 pi over 6. And so our solutions are pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. And you don't need to write this in order. I just did for this solutions here, but you don't need to write it in order. Okay, let's take a look at another problem where it's not in quadratic form. And here it's asking us to solve the equation 2 cosine of x minus 1 plus 2 sine of x plus root 3 equals 0. The nice thing about this problem, I already like this problem because the factoring is done for us. And so because the factoring is already done for us, we can just set each of the factors equal to 0. So 2 cosine of x minus 1 equal to 0. And also do the other one for 2 sine of x plus square root of 3 equals 0. Let's solve the first factor. We add 1 to both sides. 2 cosine of x is equal to 1. Divide both sides by 2. Cosine of x is equal to 1/2. Now I'm going to look on the unit circle to see where's the x coordinate. Remember, cosine x stands for the x coordinate. Where's the x coordinate equal to 1/2? Well, it's at pi over 3 and also at 5 pi over 3. So 2 places or 2 angles that give us 1/2 are pi over 3 and 5 pi over 3. And so let's finish that off for the other factor, 2 sine of x plus root 3. We can get rid of the root 3 first. Subtract it on both sides of the equation. And when we do that, we get 2 sine of x is equal to 0 minus root 3 is just negative root 3. Dividing both sides by 2, and sine of x is equal to negative root 3 over 2. So now looking for the y coordinate, sine stands for the y coordinate, where it's negative root 3 over 2. Well, that happens at 4 pi over 3 and negative root 3 pi over 2, which is again 5 pi over 3. Let's write that down. So here we have pi over 3, or sorry, 4 pi over 3, and then 5 pi over 3. So actually we have three solutions. 2 of them are being repeated. So I'll just write the solutions up here. So for the homework, we would type in pi over 3, 4 pi over 3, and 5 pi over 3. So 3 solutions for this equation. Okay, let's take a look at the last problem together, 7. Solve the equation on the interval 0 to 2 pi for cosine of x plus 2 sine x cosine x equals 0. So for this is not quadratic. We don't see a squared, but we're going to use the factoring process to solve this. And how we can approach this is, you can factor if you see 2 terms or several terms being added or subtracted, and you see they have common factors. Here the common factor is cosine of x. So we know we can factor the cosine of x out. So factoring, a lot of students get confused, like factoring is just dividing out the term. So you can think about like what happens if we divide out cosine of x from cosine of x itself, and you're also dividing it out from cosine of x. So what is cosine of x divided by cosine of x? A lot of students think that it just cancels out and just disappears. But think about when you divide a number by itself, what happens? Like if we were to divide 3 by 3, that doesn't just become 0, right? 3 divided by 3 is equal to 1. Well, the same concept applies when you're dividing a term by itself, it becomes 1. So dividing cosine of x or factoring cosine of x from itself, you get a 1. The same thing if you divide cosine of x from 2 sine x cosine of x, you're left with 2 sine of x. So the factoring is done. The factoring, you got 2 factors, you got cosine of x and 1 plus 2 sine of x. So we have to set both of these factors equal to 0. 1 plus 2 sine of x is equal to 0. So cosine of x is equal to 0. Let's look to see on the unit circle, where is the x coordinate 0? Well, the x coordinate is 0 at pi over 2 and also 3 pi over 2. So 2 angles that give us 0 as its x coordinate are pi over 2 and 3 pi over 2. And let's solve for 1 plus 2 sine of x equals 0. That'll give us, let's see, negative 1 over 2. And the y coordinates where gives us negative 1/2. Let's see here, we have negative 1/2, 7 pi over 6, and negative 1/2, the y coordinate is 11 pi over 6. So again, 2 solutions for that factor. We have 7 pi over 6 and 11 pi over 6. So 4 solutions, pi over 2, 3 pi over 2, and 7 pi over 6, 11 pi over 6. Okay, that is an overview of 6.5 trigonometric equations. Again, at any point, if you have any questions, feel free to reach out. I hope you have a great rest of your day today.